In section 17 for the warm-up, we're asked to fill out a table of values for two different equations. One is y sub 1 equals negative x plus 3. So that's this equation right here. And the other equation is y sub 2 equals negative 2x plus 1. Now to fill out this table of values, there are a number of things we can do. One of the basic things we could do is take all these values and plug them in to create the table of values. Not too bad if we had one equation and just a couple values to plug in, but the fact that we have two, there is another way we can do that, and that involves using the graphing calculator. So I'm going to show you how to do that. So into y sub, or to graph this, we're going to go to y equals, and in y sub 1 we're going to type the first equation, which is negative x plus 3. We're going to arrow down. And our second equation was negative 2x plus 1. Now that we have those entered into the calculator, then we can start to create a table of values from that. So to set up our table, we have to find the table set menu, which is right here in the window. But notice it's in that blue, so we're going to have to hit the second button before we hit window. And we'll get to this menu that says table start and delta table. Based on the fact that our table, if we flip back to it, starts at negative 2, that's where I want my table to start. I don't want to start it at 0 or 4 or anything else like that, because I want to actually see negative 2 as my first value. So I've already typed that in. Table start is negative 2. And this number right down here, delta table, basically wants the spacing. So from negative 2 to negative 1, it's a spacing of 1. We want a value at every consecutive integer. So I'm going to leave that as 1. These two down here, independent and dependent, we're going to leave that as auto. We want the calculator to do the work for us on that one. All right, now what we need is the actual table itself. So to get the table, we do second graph, and that will pull up the table. And then we can just take these values. This is y sub 1. That's the first equation. We have the negative x plus 3. And then this here is y sub 2, which is the negative 2x plus 1. And we can transfer those over to the table. Question 2 on that says, for what value of x is the y coordinate the same? So basically what we're looking for between these two equations, is there a place where they have the same y value? It appears to be right here. So we have a y value here of 5, and that occurs at negative 2. So the value of x, where the y coordinate is the same, is negative 2. The third question says, what does the shared coordinate mean graphically? So that indicates to me that we should probably take a look at what the graph is. So I'm going to go back to my calculator here, and instead of looking at the table, I want to actually see the graph. So I'm going to hit the graph button. And there's that first line. And our second line is showing up as well. And the place we're really interested in is right here at negative 2 for the x. Right there, negative 2 comma 5, what's significant about that point, it's the intersection of the two lines, which is essentially what we're asked to find. So graphically, that means the graphs intersect at negative 2 comma 5. It's a shared point, a solution to a system of equations. In activity 1, we're taking it a little step further. Now we have those values, negative 2, negative 1, and so on for the inputs, but now we have 6 equations to look at, y sub 1, y sub 2, and so on. So the directions say use the chart above to find the coordinates of the points the two equations have in common. Write each answer as an ordered pair. If there is no common point, write none. So for the first one, we're looking at y sub 1 and y sub 2. We're looking for the first two equations. So once again, we're looking for where the y coordinate is the same. And it appears that it's right here. There's our y coordinate that's the same. Oops, sorry. I have to grab the highlighter there. Here we go. That's where our two y coordinates are the same. Now our answer we're going to write as an ordered pair, which means an x and a y. The x is the input, negative 2, and the y is the output, which is 5. So our answer for that one would be negative 2 comma 5. And y sub 1 and y sub 3, it's the same idea for that one, except now we're looking at two different equations. We're looking at these two, y sub 1, y sub 3. So we're looking for where they have the same y coordinate, and I see it right here. So then my solution would be a 0 for the input and a 3 for the output, and that's my ordered pair. And number 3 is the same type of thing. We're looking at y sub 4 and y sub 6. What's interesting about y sub 4 is it's a constant function, so the output is always 1. And here we're just basically looking for where is the output 1. And that's when x is 0. So we have 0, 1 as our solution. So the rest are kind of straightforward until we get to number 6 and number 7. So number 6, we have the equation y sub 1 and y sub 6, negative x plus 3 and negative x plus 1. So if I look at those values, for the y sub 1, I have a 5, y sub 6 is 3, no match there. 4 and 2, no match. 3 and 1 is no match. And 2 and 0 is no match, and neither is this one. So what ends up happening is there is no point of intersection based on the information that we have. But I can show you guys that this actually doesn't ever have an intersection. It's a matter of taking a look at the equation itself. We have y sub 1 is negative x plus 3, and y sub 6 is negative x plus 1. I'm going to graph those two and see if there's anything special about them. I'm pretty sure there is. So if I go back to y equals, I'm going to clear out this keystroke history. So y equals, I got negative x plus 3. It's already there. I'm going to clear this guy out. And I'm going to type in negative x plus 1. And let's see what happens when we graph. And hopefully from the graph you can see that those two lines, the blue line and the red line, are parallel. They will never intersect. Now the reason I can tell that from just the equation itself is looking at the slope, and that's the number that's in front of x. In this case, they both have a slope of negative 1. Because they have different y-intercepts, they'll end up being parallel lines. And for question 7, it's the same idea as well. Same slope, but a different y-intercept. They're parallel, and therefore will never intersect. In activity 2, we're looking at the systems graphically. So we're taking a look at the graphs of the two equations and finding out the point where they intersect. So here's one equation. This is my negative 1/2 x minus 2. And this is the other one, y equals 3x minus 2. I'm just looking for the point of intersection, which is right here, and that's the point 0, negative 2. Same thing with question number 2. We're looking for the place where the two graphs meet, and it appears that they meet at 2, 4. And that would be my point of intersection, a solution to the equation. Again, 3 and 4, the same type of thing. We got 1, 1, and 2, 4. 6 is one of those special cases. Once again, the slopes are the same, but they have different y-intercepts, and I can tell pretty much from the graph there that they're going to be parallel lines and that there will be no point of intersection. So there is none. I kind of like number 5 because we look at the y-intercepts. There is no y-intercept in this case. We call it 0. So we have y equals 2x plus 0, and we have y equals x plus 0. Those two graphs will intersect at the origin. Kind of a neat thing. And also on number 7 and number 8, those are unique situations because we have those special kind of lines, the horizontal lines. Y equals negative 3, and then it's intersecting another line. Again, we're just looking for the point of intersection. There it is, negative 2, negative 3. And the same thing here on graph 8, we have negative 3 and negative 3.